and then of course relayed by the air traffic controllers. And this report contains specific weather variables. It contains wind speed, it contains wind direction, the type of cloud. You heard earlier we have the cumulus, cumulonimbus, and so on and so forth. We also talk about, we also talk about the horizontal visibility as well as the vertical visibility. And then we also talk about the temperature, the dew point of the temperature, the atmospheric pressure, the precipitation and other weather, and any other information that is deemed relevant. And this weather information will require them in real time. So unlike the meteorological agencies, their information is based on predictions, we need this information in real time for the benefit of our brothers and sisters who find themselves fortunate up in the air. We also have another type of weather information we call the SPECIF data. Now it is important to note that the metadata here is generated every hour, and when need be, it can also be generated every 30 minutes. But its other partner called the SPECIF data, as rightly spelled out, is only issued when significant changes in the weather occur. So SPECIF for special weather. It's possible that all of a sudden we have thick clouds, we have rain clouds, SPECIF data is issued as warnings. Of course, we also have what we call the TAF, the terminal aerodrome forecast. You know, sometimes when aircrafts are landing and taking off, the direction of the wind also plays a very important role. So weather information around the aerodrome is also very important to help aircraft in landing and taking off. Now, if you go online, you will realize that most accidents that occur in the aviation industry usually occur mostly during landing and taking off. But during in-flight phase, it's usually safe. And I'm happy to say that one of the most safest, in fact, the safest means of transportation is air transport. Although we've lately experienced some unfortunate situations. Now we also talk about the payload. Now payload, we are talking about the carrying capacity of an aircraft, usually measured in terms of the weight. Now when you go to the airport and you are told, you buy a ticket and then you are told bring a weight of 23 kilograms times 2. Sometimes you don't understand what goes into in the background. Because all things being equal, if the aircraft carries 320 passengers and everyone is to be having 23 kilograms, then it means based on the destination and the amount of fuel the aircraft is carrying, some calculations goes into it vis-a-vis the weather and the nature of the wind at the airport to help the aircraft even to take off. So sometimes when you go excess and you are sometimes told that please go reduce your weight, we don't understand. Has anyone here experienced a situation where he's ready to pay for the excess weight but he's told no, please reduce? But the trick is that if you have money you want to pay, please check in early. Because if you don't check in earlier, by the time you get in late to check in, because of the payload balancing, you might be asked to drop off some excess weight. Just take note of that. Then we also have the runway threshold. Now, who has seen a zebra crossing before? Well, on the runway, there are some markings at the end of the runways that looks like a zebra crossing. We call it the threshold. We need the information there as well to help aircraft. And then, of course, the runway visual range, which is the horizontal distance that the pilot of an aircraft, which is on the center line of the runway, can see the runway center markings as well as the lights. Very, very important. From where I come from, my systems provides the aircraft horizontal guidance as well as vertical guidance for aircraft to touch down safely. However, although modern systems are fitted with autopilot and they can land, in most situations, per ICAO convention, the primary means of landing is manual pilot, unless it's on emergency before you use autopilot. So, well, The pilot needs to be able to see the runway before be able to do that. So you can imagine if he's unable to do that. This morning whilst driving to Koforidia, as I passed a Brugels, the fog was getting denser and thicker as I was driving along. I need to put on my highlights just to create awareness of other oncoming vehicles. So you can imagine a situation where the pilot is unable to see the markings as well as its visual or horizontal runway. It becomes a problem. Sometimes you see aircraft make an attempt to want to land, and then before you see, it takes off again. And to those who don't understand, they usually shout, "Jesus!" Nothing to fear. It's just a safe measure. And sometimes because of the nature of some hazard that we'll soon be talking about, that causes also that. Then, why are we talking about this? Of course, aviation safety, efficiency, and capacity are sensitive to weather, and the adverse weather can have negative impacts to the sector. I will be skipping a lot of the explanation, and my slides will be available after my presentation. On average, weather accounts for nearly 75% of the global aviation delays. You might wonder, your brother or sister tells you, "I'm returning from Amsterdam. I'm flying on KLM. My arrival time is 19:45 GMT. And then you get to the airport 19:30, expecting that exactly 19:45 the aircraft is supposed to touch down. But then 1900, 2100 the aircraft hasn't still arrived. When that happens, we need to go on our knees and start remembering our brothers and sisters in our prayer. And you might be wondering why. It's because of some of the impacts we will soon be talking about. You understand? Again,